All right, let's get into it. Today, we're talking about something pretty amazing, the ancient water internet. And I promise, by the end of this, you'll know exactly how ancient Greeks could send text messages using just water. How cool is that?
Okay, I want you to picture this. It's way, way back, 350 BC. You're a general in ancient Greece. You're standing on top of a mountain and it's a pitch black night. And then all of a sudden, on the next mountain over, you see it, a bright light.
It's a signal. Awesome, right? Well, not so fast. What does it actually mean? This brings us to the first huge problem those ancient generals had, the problem with fire.
See, a fire signal can't really talk. All it can do is pretty much yell, "Danger!" But if you're a general, you need way more than that. You need to know what kind of danger it is. Is a massive army about to attack? Or is it just a couple of pirate ships messing around on the coast? A simple flash of light just can't tell you any of that. So to get those important details, you'd have to send a person, a runner, or maybe someone on a horse, all the way across the mountains. But think about it, that could take hours. And in a battle, hours are like an eternity. By the time your messenger gets there, the fight could already be over. This is where the hero of our story steps in. A totally brilliant inventor named Aeneas Tacticus decided he was going to solve this problem. And his goal? Oh, it was simple, but absolutely genius. He wanted to make fire speak actual words instantly.
And this brings us to his incredible invention, what was basically a water-powered text machine.
Aeneas created something we now call a hydraulic telegraph. I know, that sounds super complicated, but let's just break it down. First, let's look at the word telegraph. It actually comes from two old Greek words that literally mean far writer. So, a telegraph is just any machine that can send a written message over a really long distance.
And the second part, hydraulic, is even easier. It just means it's run by a liquid. And in this case, that liquid was, you guessed it, plain old water. So, a hydraulic telegraph is a far-writing machine that's powered by water. Pretty clever.
So how did he actually build this thing? You'd be surprised how simple it was. First, he took two giant clay jars that had to be perfect twins, exactly the same size. Then, he filled both of them all the way up with water and put a cork in to float on top. And finally, sticking up out of that cork was a long rod, kind of like a ruler. But instead of numbers, it had messages written on it, like cavalry, ships, or even corn.
Okay, so you've got two jars with sticks in them. How on earth do you send a text message with that? Well, it all comes down to one brilliant trick, the synchronization secret. Synchronization. It's a big word, but all it really means is happening at the exact same time. That's it. And this idea, it's the absolute key to making this entire invention work. Here's the piece of genius that Aeneas figured out. If you have two jars that are identical, and they have the exact same size hole in the bottom, they will drain water at the exact same speed. It's just simple physics.
So let's see this thing in action. The sender on one mountain waves his torch. That means, get ready. The receiver on the other mountain waves his torch back, saying, I'm ready. Then, the sender drops his torch, and at that precise second, go. Both soldiers pull the plugs out from the bottom of their jars, and the water starts to drain.
All right, quick question for you. As that water is draining out of the little hole in the bottom, what do you think is happening to that floating rod with all the messages on it?
If you guessed that it sinks, you are absolutely right. As the water level goes down, the cork float goes down with it, and that means the message rod slides down into the jar. And here's the cool part. Because of synchronization, both rods on both mountains are sinking at the exact same speed.
Now the sender is watching his rod like a hawk. The very second, the message he wants to send, let's say it's heavy infantry, sinks down and lines up perfectly with the top of the jar, he quickly waves his torch again. And that's the signal for stop.
The receiver instantly sees the signal and bam, shoves his plug back into the jar, stopping the water. He looks down at his machine, and because the jars are perfect twins, the water stopped at the exact same level. And right there at the top of his jar is the message, heavy infantry. It actually worked! A detailed message sent across miles in just seconds. But hold on a second. What do you think would happen if one of those little drain holes got clogged with, say, just a little bit of dirt? Or what if one jar wasn't a perfect twin of the other? And that question brings us to a really interesting debate that historians still have today. Was this invention truly a work of genius, or
was it just kinda glitchy?
You've basically got two camps. On one side, some experts argued this thing was revolutionary. They call it the world's first data network, giving commanders real information to win battles. But then you have the skeptics. They argue the machine was just too fragile. A tiny bit of dirt, a small difference in water temperature, anything could throw off the synchronization. And if that happened, you might get the message, send corn, when it was really supposed to be send help. Whoops.
But you know what? Whether it was perfectly genius or a little bit glitchy, this invention was a huge leap forward. And it really gets to the heart of why this ancient idea of coding matters so much.
Because what Aeneas was really doing was coding. He was turning complex information into a system of signals. And that shows us that coding isn't something new for computers. Nope, it's a human survival skill that's thousands and thousands of years old.
I mean, think about it. For a general like Aeneas, knowing exactly what was coming, the difference between heavy infantry and ships, that wasn't just interesting trivia. That was the difference between winning and losing, between life and death.
So we've seen how the ancient Greeks used water and fire to send messages through the air, which kind of leaves me with one last thought for you. Did you know that much, much later, in the 1800s, people tried to build a computer not with electricity, but purely out of gears and steam? But that's a story for another time.